It's time for another podcast by George. Straight talk, straight from the heartland, that'll have you saying, "By George, I think he's got it." Now, here's George.
Hello, hi, how are you? Welcome back in to another podcast by George. Well, we're coming up on that time of year that's going to be maybe something that I remember for the rest of my life. And that is Derecho. That thing that came through the state of Iowa last year, I'll never forget it. It was unprecedented. The Derecho straight line winds in Iowa reached 140 miles an hour on August 10th. It traveled 770 miles across 8 states from South Dakota to Ohio. Total damages to homes, businesses, and farms, much of it centered in Iowa and Illinois, reached $11.5 billion. That's according to NOAA, reporting that it's up from $7.5 billion that was estimated last fall. So the damage estimate has gone up, and maybe most importantly, it's the most costly thunderstorm, quote unquote, I guess that's what a derecho is, in U.S. history, according to NOAA. And, you know, I've always been kind of a weather wonk. You can't be a news reporter and really not be a breaking news reporter, which is what I was, because a lot of that this time of year particularly can be weather related. But if you're a traveler for business, which so many people are, I mean, you're in airports and hotel rooms, what's on? The Weather Channel. I mean, if you're a hockey player. I talk to hockey players. They're weather wonks, these guys. Why? They spend all their times on buses, airplanes, and airports, and so they watch the weather very closely. So let's talk derecho. I want to talk about forest fires out west and the weather that they're generating and some other issues. And we're bringing back a friend of the podcast. You may remember him from about this time last year. It's Dr. William Gallus from Iowa State University Geological and Atmospheric Sciences Department. He's a professor of meteorology and has been at Iowa State University for 25 years. His research interests include improving the understanding and prediction of thunderstorm systems, their evolution, rainfall, and severe weather, as well as prediction of winds for wind energy. He's also been following very closely and is immersed in how climate change may be impacting extreme weather events. So, Dr. Gallus, welcome back to a podcast by George.
Hi, George. Nice to be here again.
Thanks for coming on the podcast. I'm going to start us off here with this article. I want to bring this up here. It'll be a nice beginning. A derecho watch in the upper Midwest. This is just from yesterday. Now, this was in the Oshkosh, Madison, Milwaukee, and Chicago areas. You can see the map there. It says, and this was originally reported in the Washington Post, parts of the upper Midwest and Great Lakes region are bracing for potentially destructive wind gusts ahead of an anticipated line of severe thunderstorms expected to develop Wednesday evening. Meteorologists are concerned that storms may congeal into a high-impact windstorm known as a derecho that we've been talking about, with the possibility of hurricane-force winds, large damaging hail, and a few tornadoes. Okay, let me bring this article down. I want to ask you, Bill, is this something new, a derecho watch? And are we going to have derecho watches and warnings similar to what we've known for thunderstorms and tornadoes? Can they be predicted like that?
Well, it wasn't officially a derecho watch, but the Storm Prediction Center that is tasked with providing, forecasts ahead of time for the threat of severe weather, for many years has known when the conditions look favorable for a derecho and may mention it. I have a feeling they mentioned it in the Outlook yesterday because it's fresh in people in the Midwest's mind from the event last August. And kind of the interesting thing with this event, if you think back to our derecho last August, one of the main things Iowans remember is there wasn't a whole lot of advance warning. I went to bed the night before thinking it was going to be dry the entire week. What happened yesterday, though, shows again how hard it is to forecast these events, because last night, thunderstorms did form and plowed on through Wisconsin and Chicago. But, the strongest wind gust that was measured was only, I think, around 80 miles per hour. And it was just one report. So it's going to be interesting to see what is discovered. The event yesterday may have been a bust. It may not have even met derecho standards, even though there were a lot of trees down and tree limbs blown down. It wasn't anything like the event we had last year, even though the conditions looked, really extreme yesterday. Like you could get something like we saw in Iowa in August.
Well, August, and again, that's why we're turning to you. A lot of people describe these as kind of like land hurricanes. I don't know if that may be anecdotal, not necessarily scientific, but are we going to see a derecho season, which kind of centers around the month of August, similar to how we see a hurricane season, which traditionally has been starting around September and in the Gulf and places like that?
Here in the Midwest, it does seem like most of our derechos hit a little bit later in the summer season than most of our tornadoes. So July and August are probably the most likely months, but that varies depending on what part of the country you're in. The Southern Plains, I think, can start getting derechos a little bit earlier, perhaps June and July. But basically, derechos can happen anytime that you can have thunderstorms. So typically starting up at some point during the spring, and they pretty much go away by the time you get to mid or late fall.
Now, what's the difference between a derecho and a thunderstorm? We're all well acquainted with thunderstorms. Is it simply the size of the thing? Or, when I think of thunderstorms, I think of cold fronts slamming into warm fronts and low pressure systems coming in and cooler air being a big factor in these thunderstorms. Is that not the case with derecho? And what role does drought play in this? Because this time last year we were in drought, and again this year we are in a drought.
Well, George, those are very good questions. But basically, a derecho has to meet some standards that we don't know if it meets those until after it happens. So meteorologists like to attach names to lots of weather phenomena. And when it comes to thunderstorms, most of those names relate to what we see on radar. So we can tell you the instant it is happening that this is a bow echo or this is a supercell. Derecho is the one oddball because for something to be defined as a derecho, you wait until after it has happened and you look at all the wind reports. And so you are right, it has to have a very big footprint. So it has to have many reports of damage, several reports of extreme winds, much higher than we normally see in a severe thunderstorm. So I think it's, typically winds get above 80 miles per hour at multiple locations. It has to last for many hours. So, you could just think of a derecho as an extra big and extra mean thunderstorm system.
When we talked to you last year, before we leave the topic of derecho, it was current. It had just occurred, and you were wanting to look at some more models and have some additional time to research and study this. Have you learned anything since then, above and beyond what you knew on a preliminary basis?
So yes, so it's a very fascinating. I already mentioned to you how hard it is to predict a derecho. Most of our weather prediction models did not show the derecho happening on that Monday. But the one thing we have learned, there was one or two experimental models that actually did a pretty good job of showing these extreme winds coming through. And what we've learned is Sunday night in Iowa, the night before the derecho, we were kind of sitting on a powder keg with a lot of energy in the atmosphere. And most of the models triggered thunderstorms that night. And what that did is it used up all the energy so that when Monday came, the models couldn't produce any thunderstorms. The one or two models that did a good job managed to keep the thunderstorms from forming the night before. And then when a weather system moved in Monday morning, they were able to explode into this violent derecho. And so I think one thing we've learned from that, in the future, we should pay attention. And most people, if they remember what happened the night before in Iowa, know there really weren't any thunderstorms the night before the derecho, which should have allowed us to maybe throw away all, the vast majority of the predictions, and then instead be concerned because the one or two computer models that didn't have storms Sunday night showed us getting, hit really hard on that Monday.
I mean, like I said, I was a news reporter and I was a weather chat. I mean, I'm not a meteorologist. I just kind of describe it in terms of the atmosphere. I mean, feeling juicy. I mean, you walk out and you can sense that high level of humidity and the heat. And a lot of times, if a front comes through and breaks that, I'll go, okay, it's over. I mean, there's, like you say, that energy has been taken away. But even if you have a storm come through and you can still sense that it's juicy, you're still a prospect for getting a violent storm and maybe even a derecho. Is that kind of what you're saying?
Yes. Yes. And again, just like yesterday, it sounds like we maybe over predicted how strong the winds would be in Wisconsin. I think almost everything would have under predicted how bad it would get on August 10th last year. And I think that's still a huge challenge for us. We almost have to wait for the thunderstorm system to show the whites of its eyes, to when you started having 100-mile-an-hour winds northwest of Des Moines in places like Madrid and Woodward. I think once you see that, that this thunderstorm has somehow managed to tap in and make use of every tool available in the atmosphere to accelerate the wind, and therefore, eastern Iowa in general did have a little bit more warning than those of us in central Iowa. But I think maybe from what we saw last year, we'll be more prepared to really know how bad it can get if you get one of these organized derechos.
Well, before we leave the topic here, because I did want to talk about some other things. When we talked last year, you said it was a surprising anomaly because you have to have these wind shear events, and the derecho is interesting just because of that, and because of climate change. Things are more drought stricken; they're more dry. I don't know. To sum all that up, are we going to see more of these, do you think, than we have in the past? Did any of the modeling indicate long term like that?
George, that is a very difficult question to answer. It's really related to another question that we've had more time to look into, which is how will climate change affect tornadoes? So we know as we're getting warmer, that should make it easier for thunderstorms to be more powerful. But thunderstorms that produce strong winds or tornadoes really do need some pretty strong winds to be happening in the atmosphere. And in general, climate change tends to weaken those winds. Now, with tornado research, what has been found is on the days that have the most energy, though, the atmosphere is tending to still have a lot of wind. So that's why when it comes to tornadoes, we believe there will be fewer days with tornadoes in the future. But on the days where you get tornadoes, you are more likely to have bigger outbreaks. So more tornadoes happen on any particular day, but you have bigger gaps between those days. And I think derechos might behave somewhat similarly. So we may have, more derechos as strong as what we saw in August last year, but I don't really think the frequency is going to go up. So hopefully that means, for all of us who survived the derecho last year, we won't see another thing like this for 20 to 25 years.
And that's a good way to wrap it up, really, is a weather wonk, as I mentioned. I'm kind of interested in these things, but we don't need to see any more of them. I talked about the property damage. Of course, there's always that potential for loss of life, which could have been much greater than it was last year. And we don't want to see any of that. And also, one thing that hasn't been talked about a lot, and Cedar Rapids is suffering from it right now, man, it's hot. And the tree canopy was eliminated, basically. All the trees Cedar Rapids was so hard hit. Well, that affects air conditioning and cooling and just the ability to live in this part of the country during the summer months. When it's 95 degrees and the humidity's like it is, if you don't have some shade, I'm telling you, folks, it's a hard road to hoe, and that may be one of the biggest aftermaths of derecho. Okay, let's turn the page now. I want to bring up another article here and get Professor Gallus to comment on this. Okay, so here we go. And you don't get to control what, I don't know what that is there. There's some dancing going on there in Oregon, but the headline is, what's a pyrocumulus? Oregon wildfire forms fire clouds that pose danger below. Now, this is particularly important to our friends out west that watch and listen to the podcast. Smoke and heat from massive wildfires in southeastern Oregon are creating giant fire clouds over the blaze. Dangerous columns of smoke and ash that can reach up to 6 miles in the sky and are visible from more than 100 miles away. Authorities have put these clouds at the top of the list of the extreme fire behavior they are seeing on the bootleg fire, the largest wildfire burning in the U.S. Now, this was from a week or so ago. I don't know how much that has changed, but again, let's bring Dr. Gallus back in here. That is like derecho to me. I hadn't heard or knew anything about derecho until we had one last year. I don't know anything about this at all. So fires on the ground can cause thunderstorms in the air as much as 6 miles of cloud. Is that something new, or is that something that's been known and it's just more prevalent because there's more fires?
Yeah, they've been around for forever, but you are right. I find it interesting myself that I don't think I had people had heard much discussion about these until the last 5 or 10 years. When you mentioned the morning of the derecho that you kind of knew something was going to happen because it was just so hot and steamy. So if you think about it, when you have a forest fire, the temperature can get over 1,000 degrees down at the ground. And so that's extremely hot. So pretty much the same mechanism happens to create a thunderstorm when you have a fire. And, ironically, it would be the days that are mainly sunny out west when you're more likely to form these because the atmosphere is pretty unstable. And when the fire is really heating the air very quickly, that air is going to rise rapidly, like a hot air balloon on steroids. And what it's able to do is, as it's rising, it's taking a little bit of water vapor. So when plants are burning, they're actually releasing not only soot and smoke, but little tiny droplets of water. And so if that air rises fast enough, you can start to form a cloud in the same way that a cold front can form a thunderstorm like the derecho last year. And the reason these are so bad is if you picture what happens in Iowa, when we have a thunderstorm, the winds just go out of control. They get gusty, really strong, the direction's swinging around in many different ways. And in the West, where it tends to be pretty dry, these thunderstorms produce lightning and they produce a little rain, but oftentimes the rain dries up before it can fall to the ground. And so it's going to take the existing fire, spread it rapidly in different directions. So it's very dangerous for the firefighters. And then the lightning can actually strike and start new fires.
So I would think the wind would be the biggest problem for those firefighters, as you mentioned. They don't need any wind-whipped flames. Obviously, they already have that issue. They're never going to be a real cause of any significant rain. If they were, they could put themselves out almost. But that just is. I mean, that isn't going to happen, right?
In the West. Now, ironically, if you have a forest fire in a location where it is more humid, so it's hard to imagine something like this happening in Iowa, but typically our summers are pretty humid. You can actually create enough rain in this pyrocumulus or pyrocumulonimbus cloud that you would actually dampen the fire. So it would be kind of like a self-destruct mechanism in a humid climate. But unfortunately, the US West tends to be very dry during the summer. So yeah, you don't generally get enough rain to help. Instead, you get the wind and the lightning, which really hurt your efforts.
I mentioned that the clouds could go 6 miles up. That sounds unbelievable. But really, when it comes to thunderstorms, my understanding, and again, I just have some basic rudimentary understanding of thunderstorms, they actually can go 40,000 feet up, can't they? Or 50,000? I mean, a 30,000 plus top on a thunderstorm isn't as big as a thunderstorm as we can get here in the United States or with maybe even derecho.
That's true. I would say the typical thunderstorm gets from 6 miles to maybe 10 to 12 miles high. So I think the article you showed is talking about most of the time when you get these fire thunderstorms, they're relatively small compared to the whole spectrum of thunderstorms. But there have been a few pyrocumulus clouds in the last couple of years that I think did get closer to the 10-mile height. And George, I don't know if you're familiar with this, but in just the last few years, I think with cell phones and better documentation from the firefighters, we've actually discovered that these pyrocumulonimbus clouds can produce fire tornadoes. And so ironically, I think it was 2 years ago, California set a record for the strongest tornado it had ever had. And the tornado was actually produced in the pyrocumulonimbus cloud. And it almost looks like a horrible science fiction movie that what this tornado did. It was, I think, EF3 strength, full of fire, and it spun out from the thunderstorm and plowed through neighborhoods, setting them on fire as it destroyed them and blew the homes apart.
It's apocalyptic. I mean, it looks like you say, like a science fiction movie or something from a horror film. It's hard to believe that that's our reality today. Well, We got to let him go. Dr. Gallus, I appreciate you coming on to talk about those two topics. Now, I know that you're continuing to look at these things, and particularly as they relate longer term to the climate, which is changing. I know that you're a scientist, so you don't doubt that at all. Tell us, what you're immersed in right now, what's ahead, what you're looking at and studying in your endeavors.
Well, I'm still, trying to focus on how the thunderstorm systems that in a normal summer would be affecting Iowa, frequently at night, how they grow from just one or two cells in the late afternoon or early evening into a big complex that drops a lot of that badly needed rain that we have, that we get, fortunately, in the growing season here in Iowa. But I also hope in the next year to try to explore the effect of climate change on derechos in more detail. The biggest challenge with that is one of the best ways to look into this requires that you be able to get a good weather forecast in the first place of the derecho. And as I hinted, yesterday was a good example of a failure where we thought for sure there would be a derecho. Last August in Iowa was a case where we didn't think there would be a derecho, and that forecast failed.
Well, let's hope the forecasting gets better, and let's hope the forecast is none of that stuff. Okay,
Right.
so yeah, that's for sure. Dr. Gallus, thanks again for coming on a podcast by George.
Thanks, George. Have a good day.
Folks, I hope you enjoyed that. I know I do, because like I said, I've always been interested in the weather and the news, and this combines both elements of it. And if you like Podcast by George, please, go to podcastbygeorge.com. Pick a platform. There's any number of places you can see or hear the podcast, most notably on iTunes. Subscribe there, and you'll always be able to get it on your iPhone. Go to YouTube, subscribe there, ring the notification bell, leave a comment for us, give us a thumbs up. And follow us on Facebook. A lot of people like to watch Podcast by George there. But that's going to do it. That's going to wrap it up. That's all there is. And there ain't no more. That's another podcast by George.